So the second speaker would be speaking about testable data pipelines. And yeah, this is Florian. You have the floor.
Thank you so much. Can everybody hear me well? Perfect. Thank you so yeah, thank you for coming to my talk, Testable Data Pipelines. Absolute shameless disclaimer. My main talk will be at 2 p.m. and those talks are somewhat connected, so you're perfectly prepared to join my second talk at 2 p.m. So this is actually a talk that I gave last year, and since there was a slot free, I also repeat it now. What I'm going to show you is, so we're using DBT, we are talking about DBT and focusing on testing, the testing aspects of DBT and basically the patterns that we found work well for us. My name is Florian. Yeah, maybe that's enough about myself. Most interesting thing, I have a 4-year-old and I have to buy some Lego before I fly back to Berlin. But so if you know a Lego store in Vilnius, please let me know. And a bit context sharing where this comes from. I think that matters for like how we do things. I work for a company, it's called Flatiron Health. I will give much more context about that in my second talk. What we do is basically building our medical research platform, which has certain characteristics of the data we're dealing with. So it's real-world evidence data, real-world oncology data. That means the data structures are complicated. So like data models, I don't understand till the end. I learned a lot over the years, but I do not understand our data models. And it's very sensitive data. And we do this across the globe. So it's a highly segmented environment, right? We need to isolate all the data. So how that looks. So we don't have one pipeline that runs from source to end. We have 1 million pipelines that all run in restricted environments. Of course, apply some transformations, some models, and some privacy enhancing techniques. And when the data is more anonymous, we move the data to the next environment. But we don't have big data, right? So I mean, the databases we're dealing with are maybe hundreds of gigabytes, but not petabytes, right? So big data is not our problem. So we don't have to move 2 petabytes across different databases. So that's not the scope of what I'm going to talk about. Here's the agenda. I have one SmartyPen slide, just one. And then I want to introduce DBT, right? It's a little bit of an introductory level. I want to introduce the concepts that matter for the talk, for testing, and then I'm going to talk about how we test our data pipelines with DBT. Okay, let's start with the SmartyPen slide. I felt I had to mention LLMs, so I asked an LLM to write a text about software architecture, and it should convince you that a software architecture is good if and only if its components are testable and observable in isolation. What I mean by that is I think data tests are somehow on the edge between testability and observability, right? Because for data tests, so unit tests, pure testability, and for data tests, you need data flowing, right? And I think that merges somehow the concepts from classical software engineering about testing stuff and observing stuff. And I think the lessons that at least I learned from building systems, when you ensure that you can isolate your components, whatever this is, right? A function, a class, a module, whatever your component is, if you can test your module in or your component isolation and observe its behavior in runtime, you get a lot of other important characteristics out of the box, things like security and performance, right? Because you can evolve the system or the components independently. So think about this. Happy to disagree with me, but that was the SmartyPen slide. Now let's look at some code. So I want to introduce you to DBT. So DBT, who of you uses DBT? Okay, that's very awesome. For the use of DBT, some of the things will of course be repetition for the people who don't use DBT. So from my point of view, what DBT does, it introduces like software engineering practices to SQL. That's basically allows you to write modular SQL code, allows you to declare something like functions, reuse your SQL code, and test it. And with since last year, DBT even allows unit tests and data tests. I will talk about this in a second. So just for the people who use DBT, this is a repetition. Of course, somehow the data needs to flow into your pipeline, right? You can hard code your tables and databases. You should not do that. So the concept of dbt to declare your sources are sources files, and there was some which are important for testability. And when you think about deployment scenarios, we have staging systems, test systems, and so on. So what we do is we allow us to override the sources, like the locations, the database, and the schemas in runtime with environment variables. We don't have to do that. There are a million other ways. But for us, what works well is basically being able to override everything, the runtime behavior with environment variables. So we are able to specify those variables. So dbt knows where to read the data from. And then you declare your tables and maybe the columns. The columns are optional. You want to declare the tables, for example, when you write tests, as the columns when you want to write tests. And what we do, a pattern is there's one source file per source table. You can write one YAML file with 1 million lines of code. It's a nightmare. So basically a good pattern for us is one source file per tables. And dbt doesn't restrict you to tables, right? This dbt can also reference files if your data warehouse allows that, right? Depending on the technology. For example, in Snowflake, you can also extern like a S3 bucket. You can declare this external resource and read a JSON file, right? This also works as a dbt source. Okay, that was dbt sources. The next important concepts, major concepts, are SQL models. A SQL model in the end is a SQL file which lives in a certain directory, like a models directory. And what dbt does is dbt uses the Ginger templating engine, so you can use Ginger syntax for generating SQL. dbt brings in some built-in macros. For example, the sources that I just showed you, you reference them with those curly braces. So the dbt is able, when it compiles, to know, okay, this dbt model is connected to that source, and will then create SQL that runs in your data warehouse. You can also create custom macros. For example, like the total amounts macro. That is kind of a concept that you implement a function that you can reuse across different dbt models. So a concept that SQL does not really support natively. Okay, that's like the backbone of your dbt pipelines are SQL models. dbt also supports, since 2 years, I think, Python models. If your underlying warehouse supports Python models, right? So that's not, so dbt basically allows you to pass this through, but dbt would not allow you to run a Python model on a Postgres database. So your data warehouse needs to be able to natively execute Python code. I think it's the Snowflake, BigQuery, and another one. But yeah, the list of providers that support Python might have been updated. So if your data warehouse supports Python, the execution of Python code, then a Python model is simply a Python file in your models folder, and it needs to have a function with a special syntax, like a model function, which gets passed in a dbt object and a session, and it has to return a data frame. It can be a data warehouse native data frame or a pandas data frame, and then dbt does the translation for you. Important to understand is even if you work with pandas, the code still runs in your data warehouse, so it doesn't run locally, right? It will send the whole transformations in your data warehouse, and the pandas data frame is written to a table inside your data warehouse. And then you can use this dbt object in the same style as you use the macros in SQL code. You reference your sources, and of course, since now it's Python code, you can just import your own functions. And that's like a strong case, or like it's a huge benefit for using Python models. Have drawbacks, of course, but this is of course like a huge benefit of Python models that now it's just Python, right? Yeah, okay. Putting all this together, you get your DAG, your lineage graph. So when you look at all the models, so let's say we have one data warehouse model or like a MART model. Then we reference our staging models with the built-in macro ref, which basically references other dbt models. The Python models use the dbt like source function to reference sources. The same thing applies to the SQL models. They will use the built-in source macro to reference the sources. And all that together gives you then a data pipeline that looks like this. This is generated from the dbt UI. There's a dbt docs generate command that basically creates a static, like a web server with static files where you basically can inspect your data pipeline. That's very convenient because you get this out of the box. Okay, I think the last concept I want to cover are materializations. So this is basically how you tell dbt how to write your data. There's a profiles file where you basically also put in your, I mean, you don't put in your credentials, but you reference your credentials, which of course lie securely in a secret store. You can define a profile. Let's say this is a Snowflake profile, and you basically here you specify the database in the schema to where the data is written. The schema is a base schema, right? You can add suffixes. I will explain this in a second. And you can, of course, write the target, overwrite the target database on a model level. But typically, I think it's a good idea that a dbt project writes all models to the same database. But there are, of course, cases where it's a good idea to write the tables to multiple databases. And then in the main configuration file of your dbt project, you can specify the target schemas or more precisely. So there are those schema annotations where you basically can group your tables in a special schema. So this staging will be added as a suffix to your base schema. You don't have to do this, but sometimes it's a good idea if your data pipeline has different layers that you materialize the tables in different schemata. And then you can choose materializations options. Here I chose that the staging models are materialized at tables and the data warehouse option are materialized at views. The typical considerations, when you decide between table and view apply, that things that are compute heavy, you probably should compute only once. Views have the advantage that in your data warehouse, you have the definition of the view, like the SQL code, right at the hand. It might sometimes convenient for debugging because you don't need to look at the compiled code. But the Python models can only be materialized as tables, which kind of makes sense. And also Python models can only consume tables and views. There are other materialization techniques like ephemeral models, which basically renders them as CTEs, which would not work with Python models. Okay. Yeah, that concludes a quick look at dbt. Now I want to really talk about testing. And I want to start with data tests, which is maybe some words before that. So the way how I look at tests, how we do this, so we have the dbt sources, then we have our code, and we have the final data. So we apply data tests on the source level, on the level like integrity tests, not null constraints, referential integrity, things like that. This is important to do that, and B, it's important because like most column databases like Snowflake, you can declare your tables with a not null constraint, but they don't enforce that. It's kind of only metadata. So if you would really want to have a null check or like a primary key check or referential integrity check, you need to write a data test for that. So basically with the source tests, we verify that our expectations on the source data are somehow met. Then comes our pipeline. For that, we write unit tests. So for the Python code, Python unit tests, for the SQL code, SQL unit tests, so that we get confidence that our code is correct. And then we have the final data. On this level, we write proper data tests, more like statistical data tests, because now we have a data model that we understand and on which we can formulate expectations, which you can't do in the source data. And I'm talking about tests like 70% of the breast cancer patients should have at least a M-spike biomarker test, which is not correct, but it's just like a test like this. This, of course, does not work on the source data because this data is not in that shape yet. So basically, I have kind of this funnel of testing. Okay, then the first, I still want to cover a concept for dbt tests. dbt also has packages, where basically there's a packages YAML file, and a very important package that everybody should use when you use dbt are dbt expectations. This is now provided by Metaplane, and dbt expectations is an awesome package that gives you many built-in tests out of the box, and you can really write complex test scenarios in just a couple of lines of code because they just provide a lot of macros that you can use. And an example, so as I mentioned, so you can do this on the source level. Here's an example on the models level. We have a model, an orders model. So for each model, we again have, no, that's the source. I'm so sorry. Sorry, I confused myself. So here, this is like the example where you test the source file. So as I mentioned, each table we represent as its own YAML file, because we're not only listing, one table. If it's, 5 lines of YAML, it doesn't make sense, but because we write all the tests there, so those files get very large. So what you can do is you can specify the columns, and then there's this data tests property, and you can formulate some data tests. For example, dbt built-in not null. Or use dbt expectations that you can make an assertion on the data type. That makes especially sense if those tables are generated by your ingestion framework. You can test that they are unique. And you can test like referential integrity. And then what I said, like when we jump to the end of our pipeline, when we have our final data models, then we can create more like sophisticated data tests that actually test like properties of the data. And here's an example. So first, there's the column amount, and we test that, okay, I need to get the correct that all values are between 0 and 10 million, right? In order to make such a formulation, you need to understand the data. Then you can, this is a hint how to do statistical tests. Like a very easy way is you can test the quantiles like this, at 95% of the rows should have a value of at least 1 million. That's also something built in from the dbt expectations, gives you out of the box. And you can write table-wide tests, which basically use multiple columns. Then you declare your data tests on the models level, so not in the column section. You can, for example, test that a combination of columns is unique, like the region and the year in that case. And then a bit more complicated test. Let's see if I get this correct, what this test actually does. So first, you create a new artificial column, which you can use with the column name property. You basically can provide a SQL that then on runtime creates a new property. Here basically introduce a categorical variable that's either true or false. Then we apply a row condition that we only select rows with the amount above 5 million, I think. We use a quantile and a max value. And that would say all the rows that have this property have a max value. Okay, let me see. Sorry for that. This is a year ago. I would need to think about that, how the test. Does anyone know? Can anyone read that? Yeah. Maybe I will come back to the site if you have, like, I don't want to like eat up all the time now. So it tests something like that, 75% of the rows with at least 5 million revenue are in the East region, something like that. If that's correct, I really need to think about the test one more time. Sorry for that. Okay, that concludes the section about data tests with dbt expectations. So again, like we use data tests on the source level, more simple data tests for data integrity, and then we use more sophisticated tests, more like statistical tests on the produced data models. What is with the code in between? This code we test with unit tests, and dbt allows you to write a unit test for SQL. So to introduce that, and this is another reason why it's very important that you never reference tables directly, but always via macros. For example, that you have source like a source configuration and use the source macro, because then for this model, and we remember the columns, order ID, order date, and so on, we can create another YAML file, and there's a section unit tests, and with this unit test, we can override the given data because we used like the source macros. We can say, please provide dbt, please provide this as the source data for the order items and this as the source data for the orders. And then this is our expectation. You can see that I used SQL here to like this. There's this format specifier. I use SQL to write the data. You can use CSV, JSON. You can also reference files. SQL gives you the most flexibility when you have good column names or the data types, or you don't trust that your data warehouse infers the data types correctly from CSV, which sometimes happens. Then with SQL, you're on the safe side, but you can also use CSV syntax. Okay. As you might have noticed, this test doesn't live in the models directory, but in another directory, like it's in a specs directory, which is not like the DBT recommended way. We do this because our projects are not DBT only, right? They integrate many technologies, and we still want to have all the tests at one place. So we basically also move all the DBT unit tests into a central folder. And so for that, we need some custom configuration. You basically tell DBT in our DBT projects configuration that the specs directory is also, there are also models in, so DBT should scan this directory also. Yeah, that's it. Sorry. Okay. And that concludes our the discussion of the SQL unit testing. Now, how to unit test the Python models. I mean, I don't have much to say about this because it's Python code. The question is, how does the integration of DBT in Python really works? So I bring up again a Python model, which is our customers model. And I want to point out, I import this custom function, derive region function, which I use in a DBT model. And I want to use this as an example how to write a unit test for that. So in order to set this up, this is just Python, just simple Python code, right? And in order to make this work, we have again a configuration file for our Python model where we tell DBT where it can read the code from. Because again, this code is running in your data warehouse, right? So you somehow need to bring your own code into your data warehouse. And this depends on your data warehouse how to do that. In Snowflake, they have the concept of stages, which is basically an abstraction of object storage. And we can package our own code, like copy it to the stage, and then tell DBT, and by the way, this code is under this path. And then it will work. And in order to bring this code there, during the deployment process, we use an on-run start hook, which is a macro that's executed when your pipeline starts, which is simply SQL code. We create a util schema if it does not exist. We create a stage, basically like an object in your data warehouse for holding files. And then we copy the archive from your CI or from your runtime environment into your data warehouse. So this is how we can connect. Basically, have a normal Python project setup, which works well with a pipeline that runs in your data warehouse. And with that in place, yeah, then we can just use standard we write a PyTest unit test for that. So nothing special about this. What I would point out is that the way how the code executed is different in your CI infrastructure as opposed to your warehouse. So in the CI infrastructure, that runs in memory, right? Because in order to achieve that, so we use often poetry, so we declare our functions as an internal package. So we can basically import functions conveniently from our package. And that runs in memory. When you run the pipeline, the whole code runs in Snowflake. So that's like the execution environment is a little bit different, and the way how packages is imported are a little bit different. But for the matter of testing, that should not matter too much. And finally, because we now have the unit tests also, sorry, jumping back to that, live in a subdirectory of our specs directory. And since DBT thinks every Python file that is in a models directory is a Python model, it will try to pass your Python test, unit test as DBT model, and it will fail. For that, there's a DBT ignore file where basically can specify subdirectories to tell DBT, please ignore those subdirectories. And with that, this concludes the section about unit testing and about testability in general. And to close, I want to just repeat that I showed you what works well for us in our context with more complicated data models and in those restricted environments. But we can afford that we rewrite our tables, like our MAR tables, all the time. So if you have tables that are terabytes large, you need to use incremental models, which is a different problem. It will work, but not like I showed you today. And the second final remark is, so the unit tests run in Snowflake, and you can argue that's not a unit test anymore. You can do this in your CI with DuckDB, and if you're interested how, go to my second talk. So with that, I want to close with a final quote, which I love. This works for us, and a good developer is like a werewolf afraid of silver bullets. It might not work for you. With that, thank you so much for paying attention.
We can only take one question. If you have any other questions, you have to put it in the Discord. Thank you.
Thank you. Would you say the same test could be reused in a live environment as, say, data quality tests of some live pipeline?
Yes, absolutely. So, so I again want to point to my second talk, but what we actually also do is, in order to enable rapid prototyping, we allow our data scientists basically to write code in a notebook and run the pipelines from their notebook. And the nice thing about this is you can basically write custom Python code, prototype, and with the sources, and then you fire up your pipeline, either runs in Snowflake or locally in DuckDB and executes the test. So this pattern totally works for us. That depends a little bit on the amount of, so it works. The question is how long it takes. But like in a data warehouse like Snowflake, I mean, we're talking about seconds to execute a test. So this is a thing like that also, but in our case, maybe to end, so we have sensitive data. Data never leaves restricted environments. This is why I mentioned the notebook. So it's always a remote connection. But yeah, so those tests take seconds, right? Not minutes.
Thank you so much, Florian.